welcome to Tweed's Garage. In this video we'll be doing a bit of milling and turning. Thought I'd bring you along for it. To all the old subscribers, yeah, you've seen it all before, you know how to do it, but some of you new subscribers, you might not. So we're going to go over a few things, re-go over them, do a little bit of engineering. What are we doing, Mr. Tweed? Well, previous video we were struggling with this kickstart hitting this sleeved nut on the gearbox, this adaptation, this device which converted it from a hand change to a foot change. Sort of standard Scott fitment after a while, but came out as a sort of upgrade kit from Scott. So I think this one was an upgrade one. So yeah, we've got a little issue with the kickstart hitting the sleeve nuts there. So what I was going to do, we were all chatting about it last time. If you were in the garage last time, if you were not, why not? Did you get a letter from your mum? I hope so. Yeah, so sleeve nuts go on here. These things here, I'll bring you in closer, but this thing here, and discovered really with this plate on, they don't go deep enough. There's not enough engagement with the threads. About sort of thread and a half. Yeah, about a thread and a half engagement, if you're lucky. So that's all that's holding this device on at the top here. So wanted to make it better. So we're going to do two things. We're going to do one standard but longer, and then this one here we're going to do longer but with a smaller head on. So so hopefully it will miss the kickstart. So we'll be going from a we'll go Whitworth, quarter Whitworth head to a 3/16. Okay, so we'll be doing a bit of, I've started off, found a nice bit of steel bar, big enough to turn two out of, and a big enough diameter to put the flats on for the spanner to go on, put this hex head on. So that's what we'll be doing. We're doing a sort of turning, drilling, threading, and then yeah, milling flats on the side, bit of parting off, and we'll be doing that on the lathe. And then we'll be moving over to the Bridgeport Series 1 2 horsepower. But to be creating our hex heads, we'll be holding the bar in the indexable rotary head. Thank you, Cynthia. Yeah, so without further ado, as they say, we'll go over to the lathe and make a start. So thread size we need to tap into the end of our sleeve nuts is a quarter BSF. So we've got some taps here. This is the finishing tap. I've got a taper tap to start it off here. So this is a taper tap. So for those that don't know, or have only got sort of cheap tap and die sets, or the modern machining taps that don't normally sort of bother with this anymore, you get three taps normally. You get a taper, intermediate, and a plug tap. And they just, as you can see, the thread starts off gently on the taper tap, and then the intermediate, it cuts a little bit further down, and then your plug tap is pretty much full size thread all the way along. So you start off with this one, work up to this one, and then to this one. The trouble is, in blind holes you don't get much tap cut with these, but they're handy for making a start on the thread, and then working up to this one and then finishing off with a plug tap. But we've just got the size we're using, just got a taper tap and a plug tap. But yeah, that works fine for what we need to do on these sleeve nuts. So the other thing we need is a tapping drill to drill our tapping hole in the end of the sleeve nut. So we come over to my chart here, or we can use your Zeus book. So 1/4 inch, there, British standard fine, 5.3 tapping drill, which we have sitting here along with a centre drill just to start things off. Other tools we'll be using are CNMG turning tool and parting off tool. I think this is a Sandvik one, or it's a cut down Sandvik one, works very well. So I'll be using that to part this one off, because this is ready to be parted off, ready for the head to be put on it, and then we'll turn a new one up and then move it all over to the milling machine. So first we'll part this off. Then we change back to the turning tool and then proceed to do our turning. Best practice is to have the minimum amount sticking out of the chuck, and you really want to be sort of turning square, if you know what I mean. So the diameter of what you've got in the lathe, you're only turning, you've only got the same sort of length of overhang. I think it's sort of the diameter plus half again, sort of. It is a safe sort of amount to have hanging out of the chuck, because otherwise then you start getting onto with the thinner stuff, it starts to bend. But because we want a longer length turn down on this shaft, we're going to do it in 2 bites, so we don't put too much side loading on the extended length of the bar. So we try and keep it sturdy as possible for as long as possible. So we'll do it in 2 hits. And then we just finish off with a little shoulder that will sit behind the bolt head. With the turning done, we're now popping the centre drill. And then we bring in our 5.3 tapping drill. Going down to the depth we need, plus a little bit more, because we've got to allow clearance for the tap to get the thread as far down the hole as we possibly can. So we made the hole about 23 millimeters, which brings it just to the, just before the end of this turning here, so it gives us a bit of strength, not going all the way into the head of the nut or the bolt. Bit of a weird one. Is it a bolt or is it a nut? Sleeve nut. Okay, so with the hole drilled, we then proceed with our tap. So we go in with the taper tap first, just to start the thread off. So we fire the lathe up, move the tap into position, knock the lathe off, and just push the tailstock into the tap until it'll either sort of jam and rotate, or just sort of stop. And then eject that from the chuck, put on a tapping handle and continue to tap it by hand as far as that will go. Then we take that out and move over to the plug tap. And then proceed to cut the finished thread with that. So we'll go in once, come out again, clean it out with the air, go back in it again, and then because you sometimes find the swarf builds up at the end of the hole and packs up behind the tap, so you don't get the full thread length available to you with that tap. So yeah, blow it out, go in again, clean up the hole, clean it out. That's that bit done. And then we'll part it off like the previous one. And with that done, we can then move over to the milling machine. So there you go, got the indexable rotary head down on the mill, as you saw. Took about 8 minutes, so not too long to set up. If you haven't got one of these, most people don't, you can do it on, hang on, one of these, an ER collet hex block. So you put your collets in here, and as you see, it's got 6 sides at the back. So you grip your piece in your collet, and then you can pop this in your vise, mill one side, turn it round to the next set of flats, mill another, mill another, mill another, mill another. 6 sides, or you can do 4-sided one as well. If you're only starting out, these are a worthwhile investment. They're very useful if you need to get a set of collets anyway for a small milling machine. ER32 ones are pretty good, come in a set. You can get those. I've also got same sort of collet blocks up here for the R8. What's the R8, Mr. Tweed? Right, okay, let's explain it. So these are the collet blocks, hex collet blocks. Yeah, for the R8 collets. So it's just a specification of the collet, the name. So ER and R8, I don't know. I'd be lying if I said I knew. But anyway, I can show you. So Bridgeport mills, most of the mills, smaller mills, well not smaller mills, but have an R8 spindle, take an R8 collet like this. ER32 are like this. They're shorter, stumpier. Yeah, do the same job. Some say these are better collets than these because these have only got 3 splits on them. See there? So they sort of they got to be pretty close on to grip the work to the size. That's why they're all got sizes on them. So you want to be as close as possible to the size that you're putting on the collet. These ones, because they're double split, they're split from the back, from the front, and when they clamp a lot. These, what's the best way to describe it? These clamp like this on the tip, on the nose sort of thing. Yeah, so they've got to be a nice close fit because you haven't got a lot of movement, a lot of tolerance to grip that. These ones, because they're split back and front, when you clamp them, they tend to clamp squarer like that. So there's a lot more give in these. So yeah, that's ER32. Hang on a minute, are they 32? Yes, they are. Yeah, 32 millimetre roughly at the end of the taper. So they're a 32. You get an ER40. So obviously they're 40. ER, I think 28, something like that. Smaller, 28. You know, so yeah, it just goes on the capacity of the thing that you're clamping them into that will take it. Other ones you get, these ones, Ericsson, bit rarer. Yeah, not so standard, slightly different shape and all that, but all do the same type of job. Got that? So what was I saying? Oh yeah, so you could use one of those, one of these, you know, if that's your budget. Yeah, I got them early on, very useful, but then pick this up. So this is just basically, yeah, chuck, and it's indexable, so I can turn it round. It's got a index plate on it, so you know you can cut gears on it, all sorts. But yeah, I just use it for turning nuts and bolts on. So anyway, so we've got the bit in there ready to go. Let's get rid of this. Tidy this up. Somebody's bound to come in. Right, for those that haven't seen it before, bit of an explanation how to turn flats up on the mill on a round. So what we do is we measure our outside material diameter like so, yeah, and then we measure across the flats of the nut we want to turn up, or measure the flats in the spanner like that, as long as it isn't too worn. So for those that don't know, here we go. For those that do, bit of a revision. So we measure the outside diameter of our material, so it's 0.6230, and then we measure across the flats of the nuts or bolt heads we want to turn out. So that's that one and that one. And then what we do is we take this measurement away from this measurement, and that will give us the amount of material we need to remove. And then what we do then is, because we want to take it from either side of the circle to give us our 2 flats, we divide it by 2, and then that gives us our measurement of the amount we need to take off. So we need to take 0.089 off of one 6 times, and then on the other one we need to take 0.045 twice off of the other one, and that will give us our 2 different bolt head patterns. Yeah, so you're just working out this depth of cut here from the outside of the material to the flat. Okay, let's get on and do that then. Right, here we go. So we bring the table up as much as we can see. Daylight, and then we'll sweep it backwards and forwards till it touches. We'll put it in gear first, always helps. Looks like it's touching on the outside edge. So that checks out okay. So what we'll do this one first, do the smaller amount of material first, because if we bugger it up we can carry on and make it a smaller one, just saves material. So yeah, it's 0.45 off, so we'll go 0.25 first pass and then 0.20 last pass. Yeah, and then keep moving this 4 notches on the old indexer, and that will give us our 6 sides by the end of it. One. 2. 60. 20. 30. Right. Let's get our measuring stick. Yep, fits there. Fits there. Fits there. Fits there. Nice and snug. Okay, and then we'll just sort of pop that back in the lathe. Just put a bit of a chamfer on this back edge here, probably just with a file, and just clean up the old edges on the wire wheel, and that'll be ready to go. Right, let's do the other one. And then this one is 0.089, so we'll do it in sort of 3 or 4 cuts. So there we go, our 2 sleeve nuts. Right, okay, see if this fixes the problem. That goes in there quite nicely. That's a full size one. Half of it, this one. So, although it's got a smaller head, it's the same size footprint underneath. It's got the same size shoulder as the original one there. So, okay, so that's that on. And then we'll see. And there we go. We have clearance, Clarence. An elegant solution. I know some of you suggested it. Well done. So there you go. Bit of an engineering video for you there. Yeah, and we've sort of cured the binding kickstart. Nice elegant solution. I know a couple of you suggested putting a smaller head on. Yeah, so I'm happy with that. So we can get this is nearly back together. Need to connect the linkage up, but yeah, I've misplaced the other end, the other rose joint. Don't know where it is, but yeah, have a little look around on your way out. If you see it, give us a shout, and if you see my 5/32 Allen key from my weir set, yeah, let me know. Can't remember what colour it is, and yeah, been looking for months for it. Shouldn't be able to lose them, they're bright colours. So if you like the video, give us a little like and hit subscribe. As everybody says, doesn't cost you anything, helps me along and helps Jenkins along. And yeah, we'll see you in another video. Yeah, all right. What's that, Jenkins? Yeah, wrestling with the dog. I think he's pulled my shoulder. And what's the word? Don't know. Yeah, so there you go. Hope your video. Yeah, so always upwards. But to be creating our hex, but to be Allen wrench, Allen Aren't they cool?